Welcome to Unit 3 Thermodynamics, Lesson 3, Video 4. This is our final video for this unit. So we are going to be looking at temperature range. So those instances where both delta H and delta S are the same sign, how can we figure out what temperature it's going to switch from being spontaneous to not spontaneous? And if you remember back, delta G0 was going to be our dividing point because a negative delta G is spontaneous and a positive is not spontaneous. So we can do two things. We could either, one, set delta G equal to 0 and solve for temperature, or we can derive an equation to use. So if we put 0 in and just use our symbols and solve this for T, the first thing we're going to do is add T delta S to both sides of our equation. So we end up with T delta S is equal to delta H. So I'm just using algebra. Then to get T by itself, I divide both sides by delta S. So I get an equation, T is equal to delta H over delta S. But you have to make sure that this is in kilojoules per mole Kelvin. So if we are given these two values, they're both negative values. So we know that if they're both the same sign, there's going to be a temperature range at which it's spontaneous. So with that, if we look at our values, we are given delta H to be negative 47.5 kilojoules per mole over delta S. Well, delta S is in joules per mole, so we have to change this to 0.0971 kilojoules per mole Kelvin. Negative 0.0971 kilojoules per mole Kelvin. So our kilojoules per mole cross off. We're left with Kelvin. The negatives cancel out because we have to have a positive value for a temperature because it's in Kelvin. And we get a temperature equal to 489 Kelvin. So we want to know where this is spontaneous. And if we look back at our chart, when they're negative, they're spontaneous below. So that means that this is spontaneous below 489 Kelvin. If you're not sure if it's above or below, you could put values, temperature below 489 Kelvin. You could put that in with our delta H and delta S and calculate what delta G is. And if it's negative, we're good. So let's use the first example that we did on video number 3, this one. So we're going to calculate at what temperature this becomes spontaneous. So they're both negative. So on this one, and I'm just using the values from that one, we had negative 15.77 kilojoules per mole over negative 0.24012 kilojoules per mole Kelvin. When we calculate this, we get a temperature of 65.68 Kelvin. That's pretty cold. So we know that because they're both negative, it's below that temperature. If it asks you for degrees Celsius, we'd add 273 to this number. All right. You can go ahead and work on all of the worksheets in your packet and within this folder on Schoology.